Hey guys, we've got a quiz later on today. It's only a short quiz. I think you only get 15 minutes to do it in. So in order to be successful on the quiz, there's a few things that you need to be able to do. You need to know your parents. By that we mean your parent functions. You need to be able to describe transformations in words when you've been given a function in function notation. You need to have to understand what we mean by factoring out the b. And you need to be able to calculate point by point if you've got one of those strange non-parent functions and if you've got a transformation applied to it where those points will go. So let's see what about that you can do and what you can't. So if you would like to practice the parent function card matching game, you can either look at, if you've built yourself a parent function summary chart, make sure you can match each equation to its parent. Or if you'd want to play the game, looks like this. That's a game made the other day. Careful about the silly one for the absolute value function. Don't worry about it drawing that way. And all you do is you slide things. I can't move this one. It's just a picture. Slide cards into these areas here to match a graph to an equation. If you'd like to do that, then pause this video. This is probably only going to be, it uses up my computer all day when I've got it going. But try it towards the beginning of each class period, say at about 7:15 in the morning, 8:15 in the morning, 9:10, 10:30, noon, and 12:55. It'll be open for about 5 to 10 minutes at the beginning of every class period if you want to give it a go to try and match them. Okay, so take down that information, pause the video. And moving on in 5, 4, 3, 2, 1, here we go. So hopefully you know your parents. The next thing I mentioned was you need to be able to describe transformations with words. When you're given something like this with numbers and things in it, you need to be able to know what all these different numbers and things will do. First of all, do you know which parts of this give you reflections, dilations, and translations? There you go. Reflections come from if you're multiplying by a negative, either in front of the function or just in front of the x or an x coefficient there. Coefficients, a's and b's, give you dilations. They will either vertically stretch, vertically shrink, horizontally stretch or horizontally compress your function. And then you get translations, which will shift you left and right or up and down. Okay, so let's look at some. If I put these up here, can you modify this function? So g of x will give you a new function based on f of x that will reflect it over both the x and the y-axis, and you know which of these does which one. You need to know that. That will give it a vertical stretch of 2, a horizontal compression, so that will make all x's be divided by 3. That would shift the whole function 10 to the left and shift it up 8. So have a go at that. Pause your video. Let's see if you've got it right. Oops, don't know what I'm showing there. Come on, there you go. This is what it should look like. Notice here the function, there's 2 sets of parentheses that I call nested parentheses. You have to have factored this out, or that shift. If you multiplied in, that would have said negative 3x minus 30 there. Yeah? So let's double check, you know, which is your x, which is your reflection that will change all your y values, which is your reflection that will change all your x values. Well, this is outside the function, so this changes y values. And if you're changing y values, say from a positive y value to a negative y value down here, then you will be reflecting over the x-axis. Anything that's happening inside your function is going to change x values. So this is going to, if you changed x values, say you had a point over here, say with an x value of positive 4, if you changed it, reflected it, so your x value was negative 4, look what axis you just popped over. It was your y-axis. So moving on. Right. What do we mean by factoring out b? . Again, we've got this great big thing here. Your coefficient in front of the x, if there's something in front of the x, like a negative sign or a number or both, if you don't factor it out, then your horizontal shift is going to be wrong. If you've got lots of stuff happening inside your function, the only thing that should be in front of your x is a parentheses. If you've got a number sitting right up next to the x or a negative sitting right up next to the x, and if there is a horizontal shift as well, your horizontal shift is going to be wrong if you don't factor out your reflection of the y-axis and your any horizontal dilation. So here is a nasty, horrible one. Try this. Here we're looking at the cubic function. So everything on the inside here, everything inside what's being cubed is going to be stuff that messes around with your x values. Definitely got a reflection of the y-axis because that x is negative. Now you want to rearrange this. I would put the negative 3x first plus 15, then factor it out. I deliberately put a silly number at the end there so you know you don't have to play with it. Okay, try it on your own. Which way do you think this is going to shift it? We're not looking at the going down 600. We just want to look at how far will it shift left and right. Is it going to go to the left or is it going to go to the right? And I hope you got the answer to be, it is going to shift right by 5. If you didn't get that, did you do this? Did you first of all rearrange it? Then if you factor out, you can only have a parentheses in front of the x. You've got to get rid of that minus 3. You factored it out by dividing it away from this term. So you also have to divide it away from this term, which makes your plus 15 become minus 5. So you're moving to the right by 5. And the last part of the lesson today. You can choose an easy one or a more challenging one, or why not do both? What would be the new coordinates of point A if you were building these two functions, h of x and g of x? And as you can see, they're both based on f of x. Well, up here is a graph of f of x. And we're not going to make you do the whole graph. Let's just look at point A. So if you look at point A here, it's at -2, -1. Now think about what you know about functions and transformations. Look, you've got something in front of that x, factor it out. That doesn't say -3. It's not going to take you right 3. It's going to take you left 3. And think about what order you have to apply things to the transformations in. It's important that you do reflections and stretches and compressions first, reflections and dilations first, and then you shift your point after that. Okay, pause your video, give it a go. And here are your answers. So first of all, put it in the right form to be able to clearly write out what your transformations are. You've got to be able to list them like this. Here we have a reflection over the y-axis. This is going to change all your x values. If your x values are negative, it'll make them positive. If they're positive, it'll make them negative. Then we're going to shift it. This is going to shift it to the left 3. So if you're shifting something to the left 3, you're actually going to subtract 3 from each x value. And this up here is going to make it move up 2. And if you're moving up 2, you're going to have to add 2 to every y coordinate. So let's start here. Reflect first. What are we reflecting? Both the x and the y? No. We're only reflecting over the y-axis, which will just change this -2 to a +2. So that's step 1. Now we're ready to shift. So we've got to subtract 3 from that x coordinate, which will make it -1. And we've got to add 2 to the y coordinate, which will make it be +1. That wasn't too bad. So if you hadn't done the next one yet, try it now. It's not as horrendous as it looks. So this time, again, we've only got a reflection over the y-axis. So that's going to make this -2 turn into a +2. Then we've got this, which is not going to be a horizontal stretch. It's going to be a horizontal compression. We're not going to multiply this by 2. We're going to have to divide it by 2. So we flip it. It becomes +2. Then we divide it by 2, and that gives us the y value hasn't changed. We had no vertical stretch. and no reflection of the x-axis. That didn't change. So first of all, we reflect and dilate, and now we shift. So all we have to do is add 5 to this x value, and subtract 4 from that y value, which would, subtracting 4 to the y will send it down 4, adding 5 to the x will send it to the right by 5. So doing that, and 1 plus 5 is 6, and minus 1 minus 4 is -5. And if you could do that and follow that, you're really ready for this quiz. You have a review tomorrow, and we have a test on Thursday. Now I have to work out how to stop my video. This is going to be fun. I don't know what I'm doing here. Stop.